Lesson 7.2, Graphing Rational Functions. Rational functions are functions written as a fraction with x in the denominator, like y equals 1 over x. The shape of the graph, as you can see on the right, is called a hyperbola. And it has two asymptotes. We have the x-axis and the y-axis. And as you can see, everything is graphed except for the domain. You can't use x as 0 because then you'd be dividing by 0. You can't divide by 0. It doesn't make any sense. And the range is everything except for 0 and the y, because as long as you have a number on top of a fraction, it won't equal 0. The only way for a fraction to equal 0 is if the top number, the numerator, is 0. In general, this is the form of a rational function. Y equals a over x minus h plus k. Oh, wait, it's a's, h's, and k's. We've had those transformations before. A stretches it vertically. H shifts to the right, and k shifts up. Notice the h is linked with the x, therefore it moves in the x direction, left and right. K is on the outside, just not connected with the x, so it goes up and down in the y. So how is this function, y equals 2 over x plus 3 plus 4, transformed? Well, we can see that the 2 is our a, so that is a vertical stretch by a factor of 2, so it's twice as tall, in other words. This was x minus h, so the only way for that to work is if it's minus a negative there, so h is negative 3. Which means it shifts, that would be left. Left is the negative direction, 3. And then this is our k, so our k would be 4, which means it shifts up 4. In order to graph rational functions, you need to be able to find the asymptotes. The vertical asymptotes are pretty simple to find. What you do is you take whatever the denominator is, you make it equal to 0, and you solve for x. And that gives you little equations like x equals 2 or x equals 3. Those are the vertical asymptotes. To find the horizontal asymptote, now there's only one horizontal asymptote. You can't have more than one horizontal asymptote. There's just one. You can substitute in a very large number for x and estimate y. Or, people usually like this better, you find the degree of the numerator and the degree of the denominator. If the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote is y equals 0. If the degrees are equal, then y equals the leading coefficients. And if n is greater than d, then there's no horizontal asymptote. Let's kind of explain why. Now, if there's a vertical shift, you'll have to also shift the asymptote by that, like if there's a k at the end. But let's pretend like we don't. Let's say we just have x over x plus 1, and then we'll vary it. All right, let's put a square on the bottom. So now n is 1. And d is 2. The degree of the numerator is 1. The degree of the denominator is 2. If I put in huge numbers, let's say 1,000,000, on the top I'd have 1,000,000. On the bottom I would have 1,000,000,000 and 1. Which is approximately 1,000,000. And so then if I divide those, I'll end up with 1 over 1,000,000 which is approximately 0. So that's why it's y equals 0. If our degrees are the same, let's try here. So they're both degree 1. If I put in a huge number, like 1,000,000, 1,000,000 plus 1 is pretty much the same thing as 1,000,000, which gives me 1,000,000 over 1,000,000, which is 1. Oh, wait. What are the leading coefficients? 1 and 1. So it's 1 over 1, which is 1. So that's why it's y equals the leading coefficients. All the zeros canceled except for the leading coefficients. Lastly, if I make the degree on top larger, let's plug in a big number. And again, 1,000,000 plus 1 is essentially 1,000,000. So on the top, I have 1,000,000,000,000. I'm dividing it by 1,000,000. That gives me 1,000,000. And if I used a bigger number, it'd be even bigger. So that's why there's no horizontal asymptote when the degree on the top is larger. So let's try this example. What are the asymptotes here? Well, we look at the degree. The degree of the numerator is 1, because it's just x to the first. The degree of the denominator is 1, because it's x to the first. So n equals d, and it says if n equals d, then it's the leading coefficients. The leading coefficients are 2 over 3. So our horizontal asymptote is y equals 2 over 3. So horizontal asymptote. We also need to find our vertical asymptote. The last slide said you take the denominator equal to 0 and solve for x. Divide by 3, and we got x equals 2. So a vertical asymptote is at x equals 2. Horizontal asymptote is y equals 2/3. Notice those are both equations. X equals or y equals. That's because they're lines. They need to be written as equations of lines. Something else for a graph that's important is domain and range. The domain are all the x values that you can graph. Well, for a rational function, that would be all the x values except for the vertical asymptotes. The range is all the y values covered in the graph. So for a rational function, a simple rational function, that's usually all the y's except for the horizontal asymptote. All right, we can graph by finding the asymptotes and then making a table. So let's try graphing this. Let's start off with our vertical asymptotes. It's pretty easy. You take the denominator, which is our x plus 3, make it equal to 0. So we end up with x equals -3. And we can put that on our graph. Horizontal asymptote, you can plug in a large number or do the degree of the numerator and denominator. I'm going to do that. The degree of the numerator is 0 because it's like 2x to the 0. The degree of the denominator is 1 because it's like x to the first. So n is less than d, which means our horizontal asymptote is y equals 0, except we have the plus 4, vertical shift of 4. So it's really y equals 4. So if you'd like, the domain is everything except for the vertical asymptote. So our domain is everything except for x is -3. And our range is usually everything except for the horizontal asymptote. So it's probably everything except for y equals 4. So let's make a table. I'm going to grab my calculator, go here to functions. I'm going to add my function, which was 2 divided by x plus 3 plus 4. And if you want to see the graph, there's the graph. And we can go over to our table, which I've set to go from -6 to +6. -6 is 3.33. Negative 5 is at 3. Negative 4 is at 2. Negative 3 is undefined. And notice that's at our vertical asymptote. Negative 2 is at 6. Negative 1 is at 5. 0 is at 4 2/3. 1 is at 4 1/2. 2 is at 4.4. 3 is at 4 1/3. 4 is about 4.3. 5 is at 4 1/4. And 6 is about 4.2. All right, now when you draw this graph, you need to go through your points, but it's going to end near an asymptote. So like the one on the left here, we're going to drop it down so it follows along the asymptote. So at the edges of your graph should be near the asymptotes. Why don't you try number 9? Pause while you draw the graph. And it looks like that. You can see there's a vertical asymptote at x equals 0 and a horizontal asymptote at y equals 3. All right, this one we want to do another graph. We want to write it in the form with the transformations, the h's and the k's. So how would we do that? Well, a graph, a rational function is just a division. So let's go ahead and divide. We're going to divide the 2x plus 5 by x plus 2. And conveniently, that x plus 2 means we can do synthetic division. So I'll put the 2, which will become a negative 2 in there. And then the coefficients would be 2x plus 5. So it'll be very short. Drop down the 2, multiply, and add. So what is this? Well, our depressed polynomial would be, there's no x left, right? 2x divided by x is just 2. So it's 2 plus 1 over x plus 2. It was 2x to the first, now it's 2x to the 0, and then the remainder over the divisor. Of course, we're going to switch that around, make it 1 over x plus 2 plus 2. And so what are our transformations? Well, this is the h. In fact, that would be a negative h. So it's x minus a negative 2. So h is negative 2, which means a shift of 2 to the left. And the k is 2, which means it's a shift 2 up. More interestingly, a vertical asymptote. Take your denominator, make it equal to 0, and you end up with x equals negative 2. Put that on my graph. And our horizontal asymptote, if we go, look at this, if we go to the original function up here, the degree of the numerator is 1 and the degree of the denominator is 1. So n equals d, which means it's the leading coefficients, which would be 2 over 1 or just 2. If instead we used the adjusted one down here, n would be 0, d would be 1. So that's y equals 0, but we have the plus 2 at the end, so we'd add 2. So you still get y equals 2. All right, and then to make our graph, we need a table. So we'll grab the calculator, go back to the function, put in our new function, and I am just going to put in the original, I think. So that's our original function. And you can see the graph there. It looks like a vertical asymptote at -2, well, x equals -2. Horizontal asymptote at y equals 2, just like we expected. And there's my table. So -6 is 1 3/4. -5 is 1 2/3. -4 is 1 1/2. -3 is 1. -2 is undefined because that's a vertical asymptote. -1 is 3. 0 is 2.5. 1 is 2 1/3. 2 is 2 1/4. Then 2.2, and also close to 2.2, and 2.1, and 2.1-ish. So as I draw this, we go through the points, and it's going to bend, and it's going to finish near an asymptote. The other one, we're going to go through the points, and it's going to bend, and it's going to finish near the asymptote. And that's our graph. All right, why don't you try number 31? Pause while you do it. G of x will turn out to be 1 over x plus 1 plus 5 if you use synthetic division, which means you have a vertical asymptote at x equals -1 and a horizontal asymptote at y equals 5. And let's look at the calculator for the graph. So we'll go to our function, enter it in. I'm putting in the original function, but you could put in the other one. All right, and when we look at the graph, you can see there's a vertical asymptote at x equals -1, horizontal asymptote at y equals 5, and if we wanted to, we could go to the table, and there's our points, and we could make our graph.